So hi students, how are you? Today I am going to start a very important chapter, and main thing, that means this chapter most of the students feeling very tough, and although it is somewhat theoretical chapter, the structure of atom, it is important for your future study. Who will study science in class 11 12, for class 9 you have to know very nicely about this particular chapter. This chapter today I am going to explain about the charged particle in matter, famous rubbing experiment, pioneer J.J. Thomson, discovery of electron, characteristics of cathode ray, definition of electrons, discovery of proton, definition of proton, characteristics of anode rays, Thomson's model of an atom, Rutherford's model of an atom, Bohr's model of an atom, and then last atomic number and mass number. Because the whole chapter I have divided into two sections, it is not possible by one section. Now I am giving a quick review. If you like, then you please give a like button and subscribe to my channel for getting your new videos. Now I am giving a quick review or quick preview of this chapter. And then one by one I will explain. Now I am giving each and every stages, explaining nicely with the slides. You see the slide nicely, then you can understand everything. And I am showing the slide, and by showing the slide I am explaining the matter of how charging experiment has the first experiment which given us the idea of the charged, an idea of protons, neutrons, electrons, everything. Okay. So let us start about the structure of atom. So in introduction I am explaining about the how charged particles are present in matter. So it was first experienced by the rubbing experiment. Whenever we will rub a plastic or a glass, plastic, that means just like pen or plastic pencil or any plastic, whenever we will rub a piece of plastic with wool or a piece of glass with silk, then after sometimes what things we will see, it can attract or it can catches some small pieces of paper. This is a classical example. That is why these small pieces of papers are attracted. This is due to some charges, that is some changes occur to the plastic or in the glasses. Same way you see, whenever we are rubbing a balloon, and we will see that is it can attract our hairs. So this is the classical example. So later on it has been explained, that is some charge, some electrons are flowing from one body to another body, and ultimately the body will attain a positive or negative charge. For this experimentation, that is first of all pioneer is J.J. Thomson. J.J. Thomson, he has discovered and noticed first about electron on a special device he has made. That special device is the Thomson's this cathode ray tube. This is Thomson, J.J. Thomson, 1856 to 1940, and he has made this cathode ray. He has made a glass tube and make it vacuum and passes electric charges, electric current, and then he has seen some rays are coming out from the cathode. Since the rays are coming out from the cathode, therefore he has given the name of the ray as the cathode ray, and the tube he has formed, that is, he has termed as the cathode ray tube. So what are the characteristics of the cathode rays? Cathode rays emitted from metal. They always travel in straight line. They consist of negatively charged particles called electron. Like this way he has given the name as electrons, and he is the first pioneer member for giving the name of electron. They can pass through a very thin foil of metal. They are deflected by electric and magnetic field. So remember, since these particles are negatively charged, therefore they are attracted to the positively charged plate. So positively charged plates are called anode. Try to remember, the name is anode. So this anode will attract the electrons. Therefore the cathode ray are attracted by the anode. Next, so what definition he has given? So definition he has given as the fundamental particle. It is a fundamental material particle in an atom which carries negatively charged. The charge is about 1.6 into 10 to the power minus 19 coulomb, regarded as unit negative charge, and mass is very negligible, 9.1 into 10 to the power minus 13 kg. Next, Goldstein. He is Goldstein, Eugen Goldstein. So he has discovered proton. So Eugen Goldstein discovered new types of rays which were emitted from the tube and passed through the perforations of the cathode. So he has kept one perforated cathode. That is, cathode is made up of many perforations, and this perforation just like a sieve. He has kept a sieve in as cathode, and he has seen that is some rays are coming towards cathode and it is moving away from the anode, and since the cathode is perforated, therefore it is penetrating through the cathode. So he has given the name as anode ray or positive ray, just like his same experiment what the J.J. Thomson has performed by the CRT or cathode ray tube. Same experiment he has performed, and he has seen some positive rays are coming from the positive plate. Same vacuum he has done, and what things he has given high voltage, and the tube made he vacuum, and he has given the name as the positive rays or anode rays, and later on he has given the name as the proton, and he has given the definition of proton, a fundamental particle, and it is also material particle present in an atom which carries a unit positive charge, 1.6 into 10 to the power minus 19 coulomb. So remember, it is 10 to the power minus 19 coulomb, it is the charges, and the unit mass equal to 1.67 into 10 to the power minus 27 kg. So characteristics of anode ray always travel in straight lines, same like cathode ray. Anode rays consist of positively charged particles called protons. They deflect by electric and magnetic field in a direction opposite to the cathode rays. So just you see Thomson's atomic model. He has compare the atoms of an element just like in watermelon. As the seeds are entered in the watermelon, just like this way, the protons and electrons, they are scattered in an atom. So he has explained, although his experiment is a initial experiment, it was changed, somewhat changed and modified by Bohr, Niels Bohr. So you see in the left side, that is the atomic model, how the protons or electrons, they are scattered in an atom. Next, Thomson's model of an atom. An atom may be regarded as a positively charged sphere in which protons are present. The negatively charged electrons may be regarded as embedded in this sphere. The positive charge due to protons and negative charge due to electron balance each other. Thus, an atom is as a whole, it is electrically neutral. Rutherford then, he has performed an experiment with very thin gold foil. Gold is a metal, try to remember, gold is a metal by which we can make very thin plate, and that plate may be of few molecules in thickness, and he has seen the ray, that is some radioactive substance like uranium, polonium. Uranium is used maximum, and he has kept in a lid box by a perforation or by a slit, perforation or slit. With that slit, an unit charge or unit, the radioactive ray will come out, and that ray, in the path of that ray, whenever a gold foil he has kept, in the gold foil he has observed, that is the rays, most of the rays are going straight, but some rays are deflected in different direction, and few rays come directly opposite to the original ray. So Rutherford's model, what his conclusion, most of the alpha particles were able to pass through the gold foil undeflected. That is, the positive rays are the mainly alpha particles. Most of the particles are undeflected. Some of these particles were deflected by small angles. 1 out of 12,000, as I have told earlier, that is very few. This 1 out of 12,000 alpha particles come back in the same direction. That is, there must be some obstruction in the middle of an atom. Since most of the alpha particles passed through undeflected, thus most of the space in atom is empty. As a few alpha particles suffered minor deflection and a very few major deflection, thus some obstruction must be there in their path. So just you see Rutherford's model, he has told all the positive charged particles, they are present in the nucleus, it is in the middle, and negatively charged particles, they are rotating or traveling in between the area of nucleus and the circumference. Then Rutherford and Bohr, both of them has modified. You see there are, if you count the number of electrons, the blue colored electrons, there are 8 electrons. They are moving in 4 different paths, and each path or each round there are 2 electrons, and these 2 electrons are opposite in spin, and you try to identify these 2 electrons are opposite in one circle. Since there are 4 circles, there are 3 circles, 1, 2, 3, 4 circles. So in these 4 circles there are 8 electrons, they are moving into in their different directions. Features of Rutherford's model: all atoms consist of 2 particles. That is, all atoms consist of 2 parts. nucleus and extranuclear portion. The mass of the atom is mainly in the nucleus. That is, nucleus possesses protons and neutrons. The positive charge on the nucleus is due to proton. All the electrons are present in the extranuclear space around the nucleus. This is the photograph of Niels Bohr. So, about the Bohr's model, in 1913, Niels Bohr gave a theory regarding the distribution of electrons in the extranuclear space in an atom. In the extranuclear portion of an atom, the electrons revolve in well-defined circular paths known as orbits. About these orbits, in the next video I will explain. These circular orbits are also known as energy level or energy shells and designated as KLMNO or 1, 2, 3, 4, and their energy levels, that is K is less than L, less than M, less than N, like this, that is 1 is less than 2, 2 is less than 3, like this. Whenever it will increase the shells, then the energy level will increase. Next, come to the atomic number. Atomic number is Z. The number of unit positive charge present in the nucleus of an atom is known as the atomic number of the element. Atomic number equals Z. It is the number of proton or number of electron. For example, atomic number of carbon is 6, that is carbon possesses 6 proton and 6 electrons. About these things in the next video I will explain in the board. Chadwick discovered neutron by bombarding a thin foil of beryllium metal with fast moving alpha particle. So, neutron may be defined as a fundamental particle present in the nucleus of an atom which carries a mass of 1.675 into 10 to the power minus 31 kg, regarded as 1 unit mass or 1 u, small u, or it is also called 1 atomic mass unit or AMU. Mass number, that is the sum of the number of protons and neutrons present in the nucleus of its atom. So, mass number A equal to number of proton plus number of neutron. So, I am not making more enlarged or large video because earlier video I have given you 26-28 minutes and you have board. In my next video I will explain in the board everything and explain the remaining part also in the board. And today what we have discussed, that is discovery of electrons, about the rubbing experiment, characteristic of cathode ray, definition of electron, definition of proton, definition of electron, characteristics of anode rays, then Thomson's model, Rutherford model, Bohr's model, and atomic number and atomic mass. And till then you study nicely, and within 1 or 2 days I will send the next video with the help of Blackboard. Okay. Have a nice day.